We will write a series of programs that will see the transition between a very regular program using if statements all the way to using the switch cases. The very first program is called Beverage 1. The very first item, we're going to extract the beverage choice from the computer user. Notice we're asking here for a string. We're going to use a very simple determination by using if-else statement. And this is a very naive way to do it, but we're going to compare if our beverage is either coffee or tea. If that is the case, we should just output hot beverage as the problem has asked us. The naive way is to use an else immediately to output cold beverage. This is not necessarily true for the following reasons. If we save, compile, and run this program, if we enter coffee, we might get hot beverage. If we enter tea, we will have hot beverage. If I enter horchata, we got cold beverage. Soda and water, we got cold beverages. The problem if I enter sangria, I'll get cold beverage. And sangria is not part of our menu. So having this solution, we'll only have a very basic determination for coffee and tea. The rest will be falling under the else, regardless of what we have. Let us modify this and call this beverage 2. On beverage 2, we will check those specific cold beverages, which are horchata, soda, and water. For that, we need else if. Else if will check explicitly if the beverage is satisfied with the possible options we have by listing them and order them. We're using the logical OR to specifically check if those options are the ones we're looking for. Alternatively, we will check with the else by providing a default comment. This item is not in the menu. It's important to let the user know what will be the default option in case they enter an item that is not in the possible case. This is a best practice to address every time you write a program that has multiple cases, multiple conditions. If we compile, save, and run this program, we not only address all the possible 5 items from the menu, but in case we add something that is in the menu, we address it accordingly. This item is not in the menu. If we go back to our code, this code, it's okay. The problem with this code is that we don't address case sensitivity, which means if in case I put here coffee, all caps, usually when you try to get a coffee at 6 a.m., you definitely need one. And when you yell that you want coffee, this will give us the unexpected answer. This item is not in the menu. So what is wrong? If we go back to our code, this code only checks the that equals for exact equality regardless the type case. Java is case sensitive. There's one way to address case sensitivity regardless of how they do. Let's create another version of this. Call it beverage 3. If you want to address case sensitivity, beverage 3 will allow us to use that equals ignore case. Equals ignore case, regardless what the computer user gives us, it will check immediately to have a lowercase. I'm going to copy and paste this so you can see how they work. If I save, compile, and run this program, if I enter coffee, all caps, Java will recognize you're talking about hot beverage. Or even if I make coffee lowercase or title case, in all of them, Java will recognize you're talking about the same beverage, coffee. For this version, we're going to use switch case. Switch case is a selector mechanism in Java which allows us to pick the option, a case, that you would like to perform. Switch uses a selected data types to perform this action. The data types are char, int, and byte. If you think about it, those three are integers. Yes, a character is an integer if you remember. How about strings? Strings are a collection of characters. So you can think that it's a very large collection of characters. And Java will check it one by one. So the first thing we have to do is to use the keyword switch. The switch will basically request to say what will be the selector. In our program, beverage will be the selector because all of the decisions we do have to do with beverage. So beverage will be the selector. We have a couple of options. The very first option, the case, is in case the user enters coffee. If that is the case, we'll print hot beverage. I'm going to start listing all the possible options that we have, such as tea, horchata, soda, water, and those are all the 5 options. And in case none of the following options are true, then you arrive to the else, in which case is called default. The rest, if you think about it, we basically translate this if statement to a switch case. This is not correct. Let's save, compile, and run, and you will see what I'm referring to. If I enter sangria, this works very well. This item is not in the menu. The only problem is if I enter coffee, we will have hot beverage, cold beverage, cold beverage, cold beverage. This item is not in the menu. What exactly happened? If we go back to our code, in the switch case, once we address the case that we're looking for, we display what we want to do and we must include the break. The break will tell the switch case that that case has been already addressed and it's time to go home. You will see break later on in other contexts such as a loop or other emergency exits. So it's important to address break in every case. Don't forget the semicolon in each break. Another question is, shall we include a break on the default? It doesn't hurt to have it, but since the default is the very last case that we will arrive, then there is no need. If you decide to put it, that is fine, but don't waste a line code. Let's save, compile, and run this program. If I say coffee, we have hot beverage, tea, soda, water, and horchata. Sangria, this item is not in the menu. This is not perfect. What happens if I ask for coffee, yellow? We will arrive to the same concept that we got initially. Switch cases does not allow logical operators, but it allows you to use stackable cases. A stackable case means that there's a case you can put on top of another case. For example, it can be the case of coffee or the case of coffee. If either or of these executions is true, then you will print hot beverage. Similar situation happens with tea. Same as horchata, soda, water. We're stacking the entire cases. Don't forget the column. So now we have a couple of cases to address that. This is not perfect, but this works. Let's save, compile, and run this program. If I enter coffee and I enter coffee, both we got hot beverage. You can try the next ones at your own. But let's go back to our code. Can we reduce this even further? The answer is true. If you think about it, we can coffee, and tea all of them, they're stackable for hot beverage. We can get rid of this statement, and we know if it's coffee lowercase or uppercase and tea lowercase and uppercase will print hot beverage. Similar situation, that will happen when we have the cold beverages, horchata, soda, and water. Notice that now we have two stackables groups, the one with hot temperatures beverages and the one with cold temperatures beverages. Follow it by the default. This works. You can try it on your own, but this is not perfect. The reason why it's not perfect, if we save, compile, and run our program, what happens if I enter something like a combination of lowercase and uppercase? This item is not in the menu. Even if we stack those options together, it will not address the completely ignored case. Let's create another version of our program. There's one trick here that we can do. On line 18, we extract our selection, beverage. Notice that here we're gonna get the computer's user information. It will be important to pre-process that information in order to avoid the problems. We can take advantage by using two lowercase. This will allow us that the beverage into the selection to lowercase. When we arrive to switch case, we will look only beverage for lowercase option. Let's save, compile, and run this program. If I use coffee, lowercase, coffee, uppercase, coffee combination of cases, all of them will be addressed. Let's clean up our program and create our final version, and let's discuss what we did. Line 16 is the declaration and initialization of scanner. We need this mechanism in order to extract information from the computer user. Line 17, we simply talk to the computer user requesting what do you like to drink. We request the information and extract the information from the computer user, a string. We store it in a variable called beverage. Line 19, we'll convert the computer user's information into lowercase. That is to prevent any kind of lowercase, uppercase confusion. We reuse the variable beverage because a variable is a placeholder which is value eventually change, and on line 19 is changing. We use the switch as a selector for beverage. We can reduce now the possible cases for the uppercase because we don't need it. Make sure you only keep the lowercase. If you decide to keep an uppercase, just be consistent with how you're going to extract the uppercase from the user. A typical mistake is that if you have a combination of cases, Java will not work. Java will be confused, and it will not work in none of them.